Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So earlier we had seen that how many stiffness matrix will be there, right? Or this one. So now we will see that how many independent elastic coefficient was there. Now in this case, in this video we will see problem on reduced stiffness matrix. So that earlier we had seen that 21 9 for anisotropic 21 independent elastic constant was there. So with that, how to find and how that is important or that is required, that we will see in this video. Okay, so problem on reduced stiffness matrix. So just see here what is given. Find a stiffness matrix A, okay, and B. Find the stiffness matrices A and B for a 3-ply. That just see here the 3-ply, that is, this is given as the angle. First one is at 0 angle, second at 30, and third at minus 45 degree. Graphite epoxy laminate. So here it's given for graphite epoxy laminate. Okay, and having 3-ply. First ply at 0 degree, second ply at 30 degree, third ply at minus 45 degree. That is the given condition in graphite. Now for that, what condition is given, right? Assume that each lamina has thickness of 5 mm. So 5 mm is there, and how many layers are there? 3. So total thickness will be 15 mm. The properties of graphite epoxy, that E1 is 181 gigapascal, E2 that graphite and epoxy, graphite having 181 and epoxy is 10.3 GPa. Okay, that nu 1 to 2 is 0.28, G1 to 2 is 7.17 gigapascal. So this is the given things in the question. So just whatever is given in the same way, just write down that one. Okay, and now let's start with the solution. So just see here, it's given T equals to 5 mm, E1 has 181 GPa, E2 has 10.3 GPa, nu 12 has 0.28, G12 has 7.17 gigapascal. Right. So now with this, how we can find? So just see here first. First, what we will find? The reduced stiffness matrix of graphite or epoxy material. So that is that Q naught. That is the Q bar of naught. So what values are given? So just see here, 181 GPa. So 181 GPa is there. Okay, so see here. So for this here, the formula is there. 1 minute. Okay, so let's see. With this formula only, we have to put here that Q will be equal to what? AI by this one. So from Q bar of Ij will be equal to what? Sigma of HK minus HK1, right? And Aj divided. So because this we have to keep this side. So Aij, right? So in this case, what we will do? Here we are finding Aij in terms of Q, but here what we are finding? Q dash bar naught. So this is for 0 ply. That's why you just see here it is 0. This is for 30 ply, that at 30 degree angle, and this is for at minus 45 degree. Right? All are given in terms of what? Gigapascal. So that's why 10 to the power 9 gigapascal is here. Right? Now just see in the question what is given. Right? So first E1 has 181 GPa, E2 has 10.3 GPa. So just see here. Okay? 181.8 actually it is. And this is 10.35. And now the third one is how much? V12 and G12 has 7.17 GPa. Okay, so just after putting these values, just see here, these two are constant, these four are 0, 7.1. So this will give you the Q dash naught value. And how you will find that one? That I showed you, that equation is here. The similar equation will be for what? Reduced matrix also. This is for external stiffness matrix, but that we can go for reduce also. Now this is for 30 degree. That is 0 ply. Now for 30 ply, similarly we just put the values, right? So whatever the values we will get after substituting the value in the same formula, we will get like here. So along this one, now this will be the value of what? Here 7.17, that value of G is given. So after substituting the value, we will get Q dash 30 at 30 degree is first for first ply, right? So that one 1 naught 9.4, then 32.46, 54.19, then the second one will be 32.46, 23.65, 20.05, and 54.19, 20.05, and 36.0. So now just see the difference in these two. Yeah, right. Because in Q0 at 0 angle, right? So these two and this two is 0. First. Next, only the diagonals are there. So let's see how to find that one. That stiffness matrix was there, and that 21 or independent and all, how we can use that one. So in case of reduced matrix, what happened? Only diagonals are there. So diagonals of first matrix, diagonal this one as second, and this is the value of G. Now just see here. Okay, new one is given as 0.28. So just see here. So in writing in terms of 10 to the power 9, that has 2.897. So whatever is here, so it should be similar. So that also is here. So now just in this case also, whatever is here 32.46, here also 32.46. Okay. Now in the same way, here 0, so here 0. Whatever at this place will be there, the same at this place. So now just see, check here in this, it's there or not. Let's see. Okay, this is changing just the diagonal one. Now 32.46, here 2.897, so here also 2.897. So here 32.46, here 32.46. Okay, next here it is 0. Then you can see that the opposite diagonal at this top, that is also 0. So now in this case, here it's 54.19, then here also it's 54.19. Okay, now what is left? This over this diagonal we know. So now this is left. So this and this also will be equal. So now just see here. Only the diagonal will be different, and just below the first, these two will be equal. So now for this one, these two is equal. Then these two diagonal elements are equal, this one, and then these two will be equal. So means other than the diagonal element to the axis of symmetry will be there. So because of the axis of symmetry, this will be equal to this one. This will be, or just fold this one, right? So after folding, what you will get from, suppose here, because already we had seen that axis of symmetry will be the folding axis of symmetry. So just fold from here, right? So whatever the value will, after folding this, what happened? Like suppose this is there, right? After folding this, what happened? This finger will match to this finger. So we can say these two are same. So same way, after folding this one, this will get overlap to this one. This will overlap to this one, and this will overlap to this one. Hence, these are equal values. So in first case also, because here it's a 2.897, this also will be 2.897. Here it is 0, so here it is 0. In this case, this one is 0, so this also is 0. So that is for what? 30 degree. In the same way, that will be for 45 degree also. So just see here, 56.6, 56.6, 46.6. Now at the 45 degree, these two also will be equal. Only this will be different. Now this one 42.32 and this 42.32. This will be equal. Minus 42.87 minus 42 means again if we will fold like this, then these elements, whatever the elements will overlap on that because of the symmetry, that will be same. So minus 42.87, then this diagonal will be minus 42.87. This is minus 42.87. This also minus 42.87. So now just see here, from here what we can conclude. Here only two are symmetrical. But now in this case, how many are there? 4 are symmetrical. Like minus 42.87, minus 42.87, minus 42.87, and here. So total 4 are there. And here you can see the 42.3, 42.3, 2 is there, and 56.66 and 56.66. So 2 are there. Now in this case, only this is independent. Here this diagonal element does not have any same in this matrix. Okay, so this is for what? Reduced matrix of graphite epoxy. At 3 laminates are there, so Q0, Q30 and Q45. So that we will see next. Now let's see here. The total thickness of the laminate H is what? That is given as 0.5 mm. So total it will be 5 into 3, that is 15 mm. Okay, the midplane of 0.0075 meter from the top and the bottom of the laminate. Thus, the location by the ply surface are whatever the midpoint will be there. So from that surface, how far it is, right? So just see here, I'm just putting this like 5. Okay, another 5. This inside gap is not there, just to show that gap. Okay, and like this is there. So these all are just gap is not there. Now, so from here center somewhere you will find. So now what will be this one? 0.015 divided by 2. That will be the center. Center will be at what? 0.0075. So that H3 0.0075. From H2 how much it is? Because from here H1, H2, H3. For H0 that center of this one, right? And so just see H1 will be what? Minus 0.0025. H2 will be same again plus 0.0025 above and below of that one. And S3 will be just that is from the center, that is at the half distance of that one. So that as H3 as 0.0075. So if this is H3, this is H0. Above this one is H1 and this is H2 below this surface, means when they are in contact. So like this 2 is there. So here, let's see, these 3 layers are there. And okay, and these 3 layers are there. So first layer, this is H0. Then here the finger layer above this one, that is H1. Just below the pen, that is H2, and then this finger is H3. So now if from the center, if you will find from here, then what happened? This top will be of the whatever the distance will be there in the opposite direction, and so H0 will be half of this distance from the center to this one, and H3 will be positive of that one. Now whatever the difference will be there in that layer, that is here, that 0.0025 for H1, then for H2, sorry, minus, then for H2 it will be plus 0.0025 meter. So this is in meter. If you wish, you can keep in mm also. So that time no need to go for this much digits. Simply you can write this as 7.5 mm. This is 2.5 mm, and then 2.5 mm, 7.5 mm. Okay, so now we have H0, H1, H2, and H3. Okay, so now let's see here, because that HK and HK minus 1 is required. So now once we will put, and from where to where, because 3 ply is there. So now just see how this formula will be there. So for finding Aij, sigma from where to where we have to take? K equals to 0 to how many? 3. 3 layer is there, because right, if suppose 5 layer is there, then 0 to 5. So here that is from 1 to 3. Then Q of Ij, okay, into what? Hk. So Hk is what? K from 1, right? Minus 4, I'm writing for first. Okay, I'll just like A 1 1, right? That is equals to what? Q 1 1, right? Into H1. Hk is 1, so H1 minus H0. Now just put the value. So Q 1 1, H1. Let's see how much we got. H1 minus 0.0025, and H0 is minus 0.0075. Right? So just see here. And so here, this will be Qij already we found here. Right? So we have Qij for 0 degree. Right? So similarly, if we are finding for 0, 30, 45. So for Qij for 0, this we will use. Now this into AK minus 1. This we have to just multiply. Then what we will get? Matrix A, because we have to find matrix A and B. Right. So this already we found. Now this we have to. So just see, this value is already there. Right. Now HK once we are putting for first ply. Right. So that has 0. Then this we have minus 0.0025 minus of minus 0.0075. So after this what we will get? This whole thing into how much? This becomes plus. So plus 0.005. Simply you can say the 5 mm. Okay, so 0, 5. Okay, now this we got. So similarly, again this is for first Qijk. Now for the second term, that time what happened? Now we will use for this Q30. Right? So Q30 will be up to this, it's the same. Now what we have to do, you have to put 2, K equals to 2. So this becomes H2 minus H1. Now put the value of H2 minus H1. So H2 is 0.0025 and H1 is minus of 0.0025. Just substitute here. So 0.0025 minus of minus 0.0025. So after this will get added, right? So this will give you also 0.005, right? So see here, whatever the value of A will be there, this minus this one, right? Now next the third one. So just see here, third one here. Okay, so this matrix into now K equals to 3. So K equals to 3 means after K equals to 3, H3 minus H2. H3 is how much? 0.0075 and H2 is 0.0025. Just subtract that one. So 0.0075 minus 0.0025. Now after simplifying, add all, you will get the matrix A. So first what you have to do, right, before adding this one, first, let's see here, right, this way. So first, whatever difference you got, that 0.005, multiply with each term, right? You have to multiply here. Similarly, after adding these two, multiply here, multiply this two here, and then apply the addition of matrix or matrix addition. Then you will get the matrix A. Okay, so see after that, after simplifying, so the extension matrix A is, so matrix A is the extension matrix. So what is that? A equals to, so after simplifying just this one, like multiplying 181.8 into this one plus adding this into this one plus this into this one. Right, no need to multiply 10 to the power 9, just keep outside, that will be common for all. So just keep outside 10 to the power 9 minus 95, only this value. So here what you are getting 0.005, multiply here. So what we will have 181.8 into 0.005, right, plus similarly here 1 plus 109.4 into after what we will get again 0.005 plus 56.66, this term into difference of this one, that also is 0.005, or in another word 0.005 also you can take common, just multiply, just add these three, okay, and simply you will get here. So after, once you will simplify, you will get the first term as here. Just here they multiplied 10 to the power 9 also, so that becomes simpler, right? So that's why, because some power having negatives, after multiplying 10 to the power, like here 10 to the power minus 2 you will get. So after multiplying with 9 you will get 7, or just you can keep 10 to the power 9 inside also, and then in terms of that simply you can write. So this is the to find A. So just see first again, for finding A, right, A of Ij, that A matrix, what is required? Sigma K equals to 1 to and Q of Ij into Hk minus Hk minus 1. Okay, that H is height from the center to that particular one, how much height is there, right? So height is given 5 plies, if suppose 4 ply is there, then for each, like here 1, 2, 3, 4, then somewhere here at this point it will be what? Center. So from center to this, how much will be there? That will be 10. This side also it will be 10. So from here this side will be 5, this side it will be. So like that, how many are there? Number of this one, that many you have to, that means that much value of this one Hk will be there, or here only 3 plies there. So that's why what here we found this value. Okay, 3 ply. So all are given at 0, 30, 45. Now just imagine, suppose here in the same question, like they just given 0 for this one, 0, 30 minus 45. Okay, and another they can give 60. That also is possible, the 4th ply, right? Or they can give 0, 30, then minus 45, and then again 30. Then what you have to do? Just take whatever the matrix is there, that is stiffness matrix, reduced matrix, just same for both, but finally adding 0 plus 30 plus minus 45 plus 30. Not this term. After substituting and apply, what will be the reduced matrix? That into HK minus HK minus 1 that you have to find. Then only you will get the matrix A. Now here what they ask, the stiffness matrix A and B. So now we found A. Now what is left to find? B. So let's see here. Okay, and that B is called as the coupling. Let's just see here. That is extension matrix. So matrix A is named as extension matrix and matrix B is called as the coupling matrix. So just see the difference. Again it will be same. Just here see the formula. HK minus HK minus 1. That is there. This will be same. So reduced matrix will be same. Just only the formula will change, and now that will be here. What? That is how much it's difference? H square K minus HK minus 1 whole square divided by 2. So this will be the difference. Right. So now what you have to do? Just you can take 1 by 2 common. So 1 by 2 taken common out. Qijk into H square minus HK minus 1 square. So here you have to take the square root of that one square and then subtract, just like here. Let's see. Now first you have to make the square and then subtract. So now HK for 0, HK was how much? Minus 0.0025, their square minus of minus 0.0075. So now just see, once you will square this one, this term itself becomes positive. So now here this will get reduced because this term also will get positive. This term also will be positive. So then you can subtract from here. So now this value will be smaller. Earlier we got the bigger value, but now in this case that value will be smaller. So that is for first one, that K equals to 0. Now for next, again that you can add half or you can take the whole half as common. So instead of putting that much bigger bracket, you can just take with each matrix half of before that one. Now this is the second reduced matrix. Okay, then this is will be what? For second ply. Second ply is H2 square minus H2 minus 1. So H1 square. So this is for H2 square minus H1 square. Okay, so now from here, just again same thing. Expand this one, we find the square. Okay, and then subtract. After subtracting, what you have to do? Multiply here. Similarly, simplify this one, multiply here. Now the third term. So third term again half plus the reduced matrix into now 3. For third ply we are finding this H3 minus H3 square minus H2 square. So this is H3 square minus H2 square. Again simplify this one, right? Then what you have to do? Put into the, that just multiply with this one. So that B over. Now what you have to do next? Then just see here. This is the unit, whatever unit we are using. So this time this is getting a square mm. So that's why here mm square is there. But now in this case just see here, it's a meter because it's in meter only. Okay, so now after finally saying like this way, okay, you can add, multiply all the term, this term, and then you can add just like by using the matrix addition. This each element will add at the same position. So now this into this one plus this into, sorry, so this into this one plus this, so with this half into this one plus this into this one. Once you will add all the three, you will get here that as minus 3.129 into 10 to the power minus 3. So after multiplying the 10 to the power 9, that becomes minus 3.129 into 10 to the power 6. So similarly, all once you will multiply, just see here why this time this is coming less. Just see, you compare the values here. The first is of 10 to the power 9, 8, 7. Right? In this case, 10 to the power 8, 8, 8. So just see here, up range of 10 to the power 9 is there, 8, 7. But now in this case, what we can see, it's of 6. Why that is 6? Why that much got reduced? Because once we are, the small value, we are squaring that one. So even it becomes more smaller. So more smaller you will multiply means the whole value becomes even smaller. So that's why that 10 to the power 9 becomes here 10 to the power 6. Okay, so in same way here that will be 10 to the power 5. So this is what? The coupling matrix. Okay, so now finally this, so these are the long calculation. So with calculator you can do it easily. I just explained how to multiply. Don't go that rough one. You can use the calculator and simply you can multiply, and then once you have the 3 matrix, you can use the calculator. In that matrix addition is there, simply just you can add the matrix and then you can write the answer. Or else you can, if you will start showing this matrix, then that becomes very long now. So instead of doing that, do those calculation, okay, in calculator, and just write just like here whatever the values are here. Okay, so now just see quickly once again. The question is, what you have to find the stiffness matrix A and B. So we have to find a matrix for a 3 ply. So in this case, that is of 3 ply. Okay, graphite, epoxy, laminate. Graphite and epoxy is combined. For that laminate we have to find. Assume that each laminate has thickness 5 mm. So 3 is given and each having 5 mm. So total thickness is 15 mm. The properties of graphite epoxy that is given, like E1 is 181 gigapascal, E2 is 10.3, then mu12 as 0.28, G12 as 7.17 gigapascal, and all like that value is there. So from here what we will do, first we will find the stiffness, reduced matrix for all the 3 ply, right? So reduced matrix Q, okay, reduced matrix Q for 0, Q for 30 degree angle, Q for minus 45 degree angle. So these 3 reduced matrix is required. Once we have this 3 reduced matrix, then directly we can go for the formula and we can find the matrix A and matrix B. So here these things are given. So now for writing the reduced stiffness matrix, let's see here. So in first case, that we can see the diagonal, these 2 will be 0 and these 2 will be 0. 181.8 is given. This also is given. So diagonal elements are given. This will be that. So 2.89. So just see here. Here, if you subtract these 2, E2 minus G1, that value formula is given for the isotropic. Okay, E equals to 3E into 1 minus 2U, that is equals to K, that formula. So from there, once you subtract these 2, you will get how much? Here, 2.897, right? 10.3. So now in this case, this and this will be just flip. Okay, that diagonal symmetry, right? So now diagonal symmetry, if this is 0, then this should be 0. This is 0, then this also will be 0, right? Now, next for Q30. So now here again, same, this diagonal will be there, right? So along the diagonal only it will be different. Once you will take the symmetry, then this will be equals to this one, this will be equals to this one, and this will be equals to this one because of the axis of symmetry, and only the diagonal elements are different. So here 3 will be dependent on the other. In this case only this is depending on this one. Now in next case, what happened? All will be symmetrical. This here already 3. Now in this case 4 symmetry will be there. So just see here how. Okay, after taking this one, this time diagonal also will have the same. Only this element will be different, right? And after folding, this will be equal to this one, right? Then this will be equal to this one, and this will be equal to this one. So now this is the all 3 with given condition. If suppose 4 ply is there, like Q60, then another one will be there, that Q minus that Q60 degree, that Q bar. That is also that 4 reduced matrix you have to find. If suppose 0 and 30 degree is given, then only these 2 reduced matrix you have to find. Okay, so now we have the reduced matrix. Next, what is required? That according to formula, the formula is here. So in this formula, height is required. HK is first ply height from the center, second ply height, like that. Okay, so for that, what we need to find the height. Okay, so what is height? 5 mm is given and it's a given 3 ply. So total height will be 15 mm. So where it will be the center? Half of that one. So that will be at midplane will be at 0.0075, or you can say 7.5 mm. Instead of writing meter, you can use mm also, but later you have to convert into mm in last. Okay, so now from the center to this distance will be, upper one will be minus 0.0075, h1 will be just whatever the one height is there, that one height having 0.05. So subtract from here, right, that height will be getting added, so minus 0.0025. Then h2 will be what? That just opposite to that one, it will be positive of this one, and h3 will be opposite to this one, is equal and opposite to this one. So if bottom we are taking positive, so these two will be positive, and upward side it's a negative. So now we have h value also. Now just apply the formula for what? Extensional stiffness matrix. So for extensional stiffness matrix, the formula is that ai is equals to sigma k equals to 1 to 3, because here 3 plies there. 4 ply means k equals to 1 to 4. Okay, Qij k. So Q, that value of first ply you are taking. So Q first ply you have to take k. This if first ply, then Q0. Okay. Then here hk minus hk minus 1. So once you are taking the value of Q as k as 0, right? So then according to that you have to take this value. So now just for first ply, so here one h1 minus 0 means h0. Sorry, h1 minus 1. So what we will get from for this one, h1 minus h0 for first ply. For second ply, h2 minus h1, because 2 minus 1, 1. And for this one, h3 minus h2. This already is given. This is q1 for first ply. This is q. For second ply, this is q for third ply. Now just simplify this one, right? And then multiply to this matrix. Simplify this part, this one, multiply to this one, simplify this, multiply this, and then just apply what? The addition of the matrix. And finally, after adding, what you will get? This is the value that will be your extension matrix A, right? So now we found A. Now next is B. The same thing, Q reduced matrix you have to use, only the formula will be different. So now formula is what? There it was h minus hk minus 1. But here one more term will get added, hk minus hk minus 1 into hk plus hk minus 1. This term, right? So after multiplying this, what you will get? H square k minus h k minus 1 square. This one, right? After multiplying this. So this hk plus hk minus 1 just got, because couple. So one will be negative, the other one will be positive. So here these two are with difference. So here sum will be there. So after multiplying, what I will get? That will get multiplied, and finally we will get this formula. So now in the same way, put hk value, that for first ply h1. So this will be h1 square minus h0 square. This will be so h1 square minus h0 square. This will be h2 square minus h1 square. This will be h3 square minus h1 square. So again simplify this one, then just multiply. Sorry, not here. This will be h1 square minus h0 square. This will be h2 square minus h1 square, and this will be h3 square minus h2 square. Now simplify all this, multiply to that matrix, right? That reduced matrix, and then just add the what? By addition of matrices. Okay. So finally, and you can just then after that multiply with 10 to the power 9 also inside to each term. Then you will get this as the coupling matrix B. Okay. So for this question, you can just refer Mechanics of Composite Material of second edition by Arthur K. Cow. Okay. So if you have any doubt regarding this, again, you can just comment on the video or contact me so that I can clarify your doubt. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.